Welcome to the Women in AI Research podcast, the show about remarkable contributions of female AI researchers around the globe. I'm your host, Yekaterina, and I'm sharing the mic today with my co-host, Malika. Right. Reasoning is one of the big topics that is probably interesting to many people, but there is more to trustworthiness. And one of such topics that relates to trust is also robustness, right? So let's talk a little bit about robustness now. So when we deploy LLMs in real world application, almost always, or maybe even just always, encounter some variations and
Yeah.
some edge cases that might not appear in the training and evaluation data that were used for developing. From your research on AI systems that support human decision making, how do you think about the robustness of current LLMs? And what kind of failures within this area concern you the most?
Yeah. So honestly, we didn't study robustness in the context of human AI decision making yet. That would for me mean that we are running the studies where we change just a certain aspect of the underlying, phenomenon. So I don't have work that's targeting that specific aspect, but I work on robustness just looking at models that are designed to do something and how robust they are. And one thing that kind of bothers me to this day is that we have created these contrast sets, which are small bundles of data points where the data points change in just slight ways and can due to that slight change can have different labels, different answers. So we have done that for in the context of the reading comprehension data sets where you need to reason over text. And one of these data sets is Conduct UA that was done with Abhilasha, who you had at this podcast as well. And in this particular dataset, Conduct QA, we have looked into how models are reasoning about negation, which was motivated by this problem that happened in, I believe, 2020, when you would search in Google, head seizure, what now? And then that variation of a summary at the time would say, oh, you should, move the person, you should give them food, and so on. And when you actually opened the link where this information was extracted from, it was all the stuff you shouldn't have been doing. So it kind of ignored the negation and gave you all the wrong information. So we went about studying like how models reason about negation, and then we embraced this idea of these contrast sets. Garner was also one of the authors of this paper who has released the contrast sets in 2020 for various existing data sets. And there we still see when we try the best models today, like O1, when we check the consistency of O1 in the bundle of data, meaning I have one question, I have 4 passages, and these passages change just slightly. So I change how negation is expressed. I change what is being negated, or I completely undo negation and check whether the model can answer the same question in the context of these 4 passages correctly. It can't consistently do it. Very often it can't. And for me, then this, idea of testing models in this way is really powerful because we already see that we can see that really, really good models are not doing so well under this measure, which is the measure of robustness. Um, and very often it's the case, and it's the case now that I don't think this has been adopted so much in our community just because it's a slightly harder evaluation to run. You need to construct these bundles and run evaluation on each one and aggregate. It's easier when you have a single file and it's a single test set and you just run your prediction and average them. So very often I do see this interplay between sometimes we actually know what are the better measurements, but they're just not adopted because they are more complicated to run. It's a delicate interplay. And I'm gonna be honest and just acknowledge also that, benchmarks that aren't strong. So, Squad that started this whole probing reasoning was then replaced with Squad 2, and there were all the questions about, oh, I can add these adversarial things, and it kind of isn't a great benchmark anymore. Glue, super glue, whatever, they all made us make advances that led to what LLMs are today. So although I know those weren't great benchmarks, and I think even the creators of those benchmarks will say like, yeah, they are better benchmarks, they did result in progress, in tremendous progress. So sometimes, I don't want to be too preachy and be like, oh, we should use better benchmarks. When I'm like, well, seems like those benchmarks were good enough to make progress as well. So this is a little digression into, what I think a good benchmark is. But yeah, your question was about robustness. The aspect of robustness I'm really interested by is this idea of these contrast sets. And honestly, I wish we do more of that. Right.
So yeah, actually you covered my next question almost, but something that I see very common, especially in industry for people who are less AI experts, more like developers or like AI engineers. So when they start like training like models, that's what they usually do. They just train the model and they're like, okay, this is time for deployment. They just clone LM harness, scroll through the benchmarks which can be potentially relevant, the start evaluation, and that's the time for deployment. A blog post is there and the model is out. And there is no actual user experience with these models that following what you said about benchmarks, the field relies heavily on benchmarks to measure progress. But you've studied how these benchmarks are created and whether they truly capture the challenges model will face in practice. I'm curious, what's your perspective on the current state of AI evaluation, and are we measuring the right things? If not, what we should do?
Yeah, it's a big question, and I feel like I don't have a coherent answer or opinion here, just because what I do is try to make these benchmarks as carefully created and as challenging as possible. But at the same time, I have just mentioned this. I'm observing that we do make progress even though the benchmarks themselves are imperfect, right? So I don't know what to kind of conclude. Like, I don't want to be like, oh, we must fix the benchmarks right now. Obviously, there are so many issues with the benchmarks we have. Like, what is MMLU even doing? What does it mean to be good at MMLU? And then maybe the only thing I would wish to see is that people stop conflating performance on such benchmarks with any very intricate and nuanced concept like intelligence or intelligence. This is where I think we are doing a huge disservice to the public when us researchers and practitioners who know these benchmarks are probably not great, and reflection, reasoning and thinking and whatever. If we see big high numbers there, that we then report them as having associations with something like human like, right? Because we know that's not the case. And I have been, arguing with people who see performance on like medical benchmarks where model is performing really, really well on medical entrance exams. And they say, oh, this is now going to replace doctors. And I'm like, how did you went from it's good at answering questions from textbooks that are available to the internet to you will have a good healthcare? There is a huge gap there, right? So I don't think maybe I do think benchmarks are important and they serve us as evidence. And when they're done robustly and properly, we can say, well, I can point to my benchmark and say, well, you can't trust your model to be good at negation. And you probably don't want to negation to be part of your prompt if your prompting strategy is the way you want to get the performance out of the underlying model. And you should be aware of this issue in general. So they're a great pointer, and I think they're a great driver for progress. But what worries me the most is how because now we have this interplay between academic research, industry research, and a huge PR machine. Because in the end, you don't need PR to raise money in the industry. These results can then be presented to be more than they are when researchers who, are reporting those numbers do not necessarily believe that's now evidence for intelligence, evidence for a job replacement or anything like that. So that concerns me the most. And there are, some foundational questions here that are really interesting now that we don't know what out of distribution is anymore because we have no idea what the data contains actually. It kind of makes some of these basic principles of machine learning 101 train test split harder and like how do you go about evaluation when you can't be sure that your data isn't contaminated and so on. So there's some nice research foundational challenges here to be tackled as well.
Yeah, and also another aspect that we haven't touched yet is synthetic evaluation. So synthetic evaluation nowadays is a big part of evaluation of benchmarks in general. So I know that you have that sufficiently recent paper that's called What Has Been Lost with the Synthetic Evaluation. That's a systematic investigation into whether LLMs can effectively replace human annotators when creating the evaluation benchmarks. So can you just first give us a bit of an overview of what motivated that work and what you studied? And I'm in particular curious to hear what you discovered about the fundamental trade-offs between validity and difficulty in synthetic evaluation.
Yeah. So this work has started from very selfish reasons. Again, I mentioned that Abhilash and I worked on Conduct UA, and I think that's the data set I'm the most proud of so far. I think it's really high quality, and we put a lot of effort, especially Abhilasha, into looking into annotators, annotations of questions and edits. And she spent a lot of time deciding whether they are correct or not and giving bonuses and promoting good annotations and so on. It's always when we create this, challenging data sets, it's always the question of how to get the most out of your annotators who can do a good job with right incentives and so on. So selfishly, I was like, wow, that was a lot of work working with those people. And now everyone says we can annotate with LLMs. So can we? I was like, all right, maybe we can. I have no idea. Like, why not? Right? Like, let's try and see. So we basically went into this work just seeing what would we end up with if we started to do Conduct UA, not when we did, but rather, today, last year in 2024. And we had that option. We had that route of either we use LLMs or we use human annotators. So let's pretend we have actually gone with the LLM route and what will happen with that benchmark, right? So we set out to do that. And basically, we expect that if we were to do that, we would use some kind of prompting approach for producing these generations. So in this work, we have done this extensive prompting for Conduct UA and Drop. And then we check the validity, how valid those generations are based on the instructions. So basically, this is something, as I mentioned, we have done for human annotations as well. You have your guidelines, and then you check whether the annotation you get is correct given your guidelines, and then either you approve the hit or not. And similarly, we did the same thing for LLMs. And depending on which question type or edit type we were generating, we have seen higher or lower validity. But in general, the validity had seen with which is not the best model right now, it was earlier GPT, seemed reasonable. And I think if we repeat the study today, we will get even higher validity. An interesting aspect of that work we have found and kind of answers the title of the paper that is lost with synthetic evaluation. And the answer is basically the difficulty, where we have benchmarked lots of models on both the original version of Conduct UA and Drop and on our generated version. And we have seen that the performance on the generated data sets is much lower. And we have also seen that the relative order of the models is not preserved. So you can't even be using the synthetic evaluation to say, well, let me just see whether this model is better than this one. And then on the stronger, more challenging version of the data, this order will be preserved. Yeah, so I do want to say that, of course, a lot is changing with newer LLMs. And I don't want to say that this is now status quo, that this is answer for the lifetime, that never we can produce synthetic evaluations that are as hard as what a human could produce. Rather, that it's difficult to do that. So we have given our best effort, and we didn't manage to produce nearly equally difficult benchmark. So if you had that choice, and if you were in my situation where, you need to choose my hypothetical situation, I should say, where you're choosing between taking an LLM or a human annotator, we both come with challenges. LLM comes with challenges of finding the right prompt and, not being able to produce these more challenging annotations. With people, you have trouble with making them align with your sentence. So if you do choose the LLM route, you kind of need to be aware that producing the difficult benchmark might be more difficult than LLM. And I think it kind of goes back to the instructions, because what you see with good human annotations is that they violate your instructions just slightly, so that their annotation is still valid, but by violating them just slightly so, they produce better annotations, more creative, more weird annotations. And this is what makes these human authored benchmarks more challenging. Like with people are good at, if you have a really good annotator, they get this nuance. They're like, okay, I get what you want. And what I'm going to do maybe slightly different, but it's still in the realm of what you would expect. They kind of have this reasoning that, what I'm going to do is still allowed, but although you didn't explicitly say so. And with LLMs, you give them instruction and they are trained to follow your instructions. So I think for me, this is where I find it difficult to achieve difficult annotations that are quirky and fun with LLMs.
Right. So maybe coming back to those AI human teams, even for generating.
Yeah, like you get some valid annotations out, and then you can ask person, hey, like, could you make this slightly change it to make it a little bit more unusual and therefore a bit challenging? That's a good idea.
Anna, given your findings about synthetic evaluation, how should the field balance the efficiency and scalability of LLM-generated benchmarks with the need for genuinely challenging human-created evaluation? What's your vision for robust evaluation practices?
Benchmark creation is just so difficult, and it's becoming so involved. Right now, I am creating a benchmark with my student Alex and our collaborators, other students and professors at the U. And oh my God, the creation of benchmark, it has just become so much work here with these new agents that can browse the web and do all sorts of things. Now, to evaluate whether the model had actually executed the task, and here we have tasks that are both heavy on images and they need to produce something in a Google Doc or Google Sheet. So you need to check whether the information is synthesized properly in a table or a very intricate figure and so on. So now you need to check whether the model has done all those bits and pieces correctly. And every bit of that requires an evaluation script, which uses an LLM sometimes itself. So now you need to also evaluate your evaluation script. And this is just for like a single type of task in this benchmark. So it has become a lot of work to write a benchmark. So I don't know. I don't think I have like a super cohesive overview of or recommendation of what the community should be doing, because we're doing so much with LLMs and a similar technology, right? Like we have just for my own work, I have benchmarks that are these reasoning over text benchmarks, which are not benchmarks that study the usefulness of LLMs, like the way we prompt them normally, right? It's about whether your LLM is good at certain phenomena. And you don't actually know how prevalent that phenomena is in human prompts to LLMs. We know it's prevalent, like negation, it's prevalent among us speakers of, let's say, English language. But I don't know how often negation is used when people prompt it. And I don't know if now my LLM is not dealing well with negation, what is the downstream effect of that? So I have benchmarks like these. I have benchmarks which are these like web agent benchmarks where you have real tasks and you want to see how good an agent is in executing real task. And then we have these user studies, which is how do people interact. So it's very, very different, right? And for every one of these benchmarks, you would want to do something different, right? So that's why I feel like I can't give you like a very cohesive and like a single answer to this question. But I think people who create benchmarks are often people who care about evaluation and rigor and want to give the best estimate of performance. So I don't know. I think I feel comfortable with like the community doing what we are doing, although we do tend to criticize benchmarks a lot. And this comes from a good place. We are like, all right, we are doing our best, but also we are acknowledging there are all these possible issues. But yeah, looking into the future, I think it's just going to become more complicated to create a benchmark because LLMs and similar technologies are just better at what they do. That comes from my personal experience. Creating benchmark today is so much more work than the benchmarks I have created years back. And then we are going to start to deal with things like when they become really, really, really good at things, like how do we evaluate it? And I can honestly already kind of see elements of that with the current benchmark we are creating, because as I said, every bit of this evaluation script now can evaluate something that is not so trivial. So you now, for example, need a vision and language model to check whether, some part of a document looks right and things like that. So it's going to become more challenging to write them and design them, but also you want your benchmark to not be saturated super quickly. So that means you need to create difficult tasks themselves. And that is becoming more and more work because it's harder and harder to think about those problems. And now we maybe need to hire experts in their domains, and that becomes more expensive. So there is a question of how to then do this in academia, for example, like how can I get money to create this benchmark? Conduct UA costed, I think, like first, and drop costed even more. So these are not cheap things to create. And luckily, so far, industry has been generous with that money because they know that academics are pretty good at creating these benchmarks, which of course can have downsides. And one can ask, well, now you're kind of deferring this heavy load to academics to evaluate your own models. And I get that concern as well. But yeah, these are my thoughts on this. They're not super coherent, but it's just such a diverse space. So it's hard to have a single thought about it.
Let's wrap up. We have talked today a lot about explainability, what it is, what is the reasoning faithfulness, how robustness relates to evaluation. Could you summarize maybe it a little bit in the sense of what kind of picture emerges in the end, given all these about when and how much we can trust LLM, and what would be that actual trustworthy AI system, how it looks like?
Yeah, I think here it might be useful to go to that distinction between intrinsic and extrinsic trust. So in intrinsic trust, I said we need, we need to see the reasons, the underlying computations of the system, how it goes about things to then see that it's doing the trustworthy thing, and then we gain what we call warranted trust in the system. And here, the most ambitious self would love to see a version of AI systems where we can approach them and regulate them the way we regulate like aviation. And basically, if we can default to something like principles of traditional safety engineering, which means that we know that these LLMs and similar AI technologies are very complicated, and they are what we call black boxes, and they learn their solutions through data, and then they encode these solutions somehow into their parameters, but we don't have the explicit code. We don't have the solution written down. If something happens, we can't go back to the model and then correct that way its solution such that that hazard never happens before. Like we can if a plane crashes, then we look into the black box and we check what's happened, and then we go back to the system and we fix that thing that had caused it if it was the system and not a human factor. And we have regulation that says you have to do that. So it's not like, oh, maybe I'll do it, maybe I won't. It's like you must do that, right? So in my most ambitious vision of what we could achieve with interpretability, we can achieve exactly that. We have interpretability that kind of writes down the solution of the network. And this kind of connects to this idea of circuits. If we had really, really good like visualizations of these processes, and I hope we can get something like, I call them like little vignettes. It's not like a full depiction of what the model is doing, but it gives you the most important bits and pieces that kind of you can make sense of. And then you can do what I said, like basically safety engineering. You have hazard, its likelihood. If it happens, you go back and fix the problem. So if we can achieve that, then I think we can either easily have intrinsic trust, so achieve this warranted trust in a trustworthy system. And of course, that's very ambitious. And of course, there is a variety of opinions of whether that's possible. But I think that's kind of where the interpretability community, that's our goal, that's our motivation. And then moving to the extrinsic trust, which I said is not about observing internal mechanisms and understanding how the model does things, but rather seeing that it consistently does the right thing and under some evaluation scheme. Yeah, I mean, I feel here I expect to see more of what we have been seeing, just the progress in how we evaluated these systems and trying to, have the evaluation that itself is very trustworthy. And again, because LLMs are not one thing, NLP is not one thing, but rather many things, we will see many of different evaluations for different kinds of things we are trying to achieve. And as long as, going back to the discussion we had previously, as long as the community stays self-critical and realistic and scientific, I think we are going to be fine. If we flip us around and now we start to be vague, unscientific, and sloppy, that's where I would be concerned. But honestly, it's a big field, and a big slice of that are just scientists and professionals. So I think as long as we still have platform to do this research and funding, it should be fine.
Fantastic. Thanks for your comprehensive response. So how about you? Before we wrap up, what's next for your research? Are there particular aspects of AI trust and reliability that you're excited to explore more?
Yeah, I think these days I kind of look into my work having two directions. One is understanding user needs and building benchmarks to test how good we are at those needs. So now I have started to work on these agents because these are kind of things we envision people will be interacting with more, and that's becoming really exciting for me because it's really intricate and honestly blows my mind. The first time I let go of my hands and saw an agent clicking things on my laptop, I was like, what is this? Which year am I? It's just remarkable, right? And I'm interested in applications in education because through the Responsible AI Initiative that generously is, funds my fellowship to do that line of work. And then the other line of work I work on is still in the interpretability space. And I'm really excited about this idea about extracting these sparse feature circuits. If you have seen the Anthropic's biology of LLMs, it's really, I mean, you have to see it and be excited. But then again, because a lot of these, what I call vignettes, are created manually by best researchers in the world, there is a question of how can we scale this? Can we get these vignettes for any kind of phenomenon, any kind of LLM? And can we do it, automatically without paying? You can imagine. I have no idea, but I can just imagine that a research scientist in Anthropic is paid a lot. So 1 hour of their work to produce one of these is a lot of money, right? So I'm just excited to, given that work, to see, can we do this at scale? And how would we go about it? So my students are thinking about some automated way to go about that. And once you can create these vignettes, going back to my work on unfaithfulness of chain of thoughts, it would be really then interesting to see like which bits and pieces of internal computations are mismatched with what the steps are verbalizing, because there are different ways that can go about being unfaithful. And again, Anthropic biology work had mentioned 2 ways where we have motivated reasoning versus like a fool making things up. And I think we can discover way more if we do this at scale, like these kinds of mismatches. So yeah, I'm very excited about that line of work, and I want to really bring it again to this application grounded evaluations. So not just be like, okay, here is a circuit and it looks pretty and it does something, but like, okay, now that we have it, what can we do with it? How can we like bring it to, let's say, medical setting, medical application area, and actually have certain benefits that we can actually demonstrate with them. This is a lot, of course, but that's kind of what I'm excited about.
That's very exciting. And this has been such an illuminating conversation. Thank you.
Thanks for joining us, Anna. And we will see you in 3 weeks. See you then.